Okay, now you're good. Hi, everyone. Welcome to the Netdata Machine Learning Meetup. This is a live stream we'll be doing every month. Thank you, everyone, for joining us today. This is the first time we're doing something like this, so bear with us for any thing that can go wrong, any mistakes or any stuff, but you can meme about it in our Discord channel or in our Twitter account. So with us today, we have Andrew Maguire, machine learning leads at Netdata, that I'm going to add to the screen. And we also have Shyam, who is our product manager for data products at Netdata. Welcome, Shyam. I know you guys are excited about this. This is also the first time you've done this. I know, Andrew, you've been doing this for a while, right?
Yeah, this is my second time. So we'll see.
A while. Yeah.
Are you guys excited to be here?
Yeah, this is awesome. Let's go.
Yep, we've a live demo. We've got a live demo ahead of us. So let's see how it goes.
Okay, guys. Good luck. I'll be here for the Q&A, and I'll be right back shortly. Good luck, and see you soon.
Thanks, Miguel.
Cool. I'll share my screen. Miguel, I think I need you to share my screen.
Yep, here we go.
Okay, so I'll get it started. Shyam is going to start us off with some of the initial topics, and then we will move into the demo, the live demo, kind of in the middle, and then we will do some Q&A and sneak peek stuff at the end.
Thanks, Andy. Could we go to the next slide, please? Yep. Okay, so to start with, I thought it would be good if we started with Netdata's vision. So our vision is to build a global community equipped to troubleshoot the technology that runs the world. Now, that's a pretty grandiose statement, but it's one that we really believe in, and it's something that we think it's an important vision, and we think it's a worthy vision. It's worth fighting for. So I just wanted to kind of break it down a little bit to explain why we think it's important, and how that segues into what we're doing with machine learning and overall what we're doing at Netdata. So let's just kind of focus on the end of that sentence, the technology that runs the world. So what does it mean? So the modern world basically runs on servers, whether it's bare metal, it's cloud, it's serverless, everything is basically running on servers. And technology is basically so pervasive at the moment that it impacts almost everything that we humans do. Any industry that you can think of, whether it's healthcare, transportation, manufacturing, agriculture, everything uses technology pretty heavily at the moment. And what this means is that many of these services that require servers, require applications running on servers, are critical for people's quality of life, so things like healthcare, and also for the progress of humankind in general, things like scientific research. And what this also, by extension, means is that operating and maintaining these servers and these applications that run on them is a really, really important job. I can't stress the fact enough. In fact, I go as far as to say that this is one of the most important jobs in history, because you're basically running the technology that runs the world. So if you go to the next slide, I guess we can dig deeper into the question of, so who are the people who are doing this job? Who are these heroes on whom mankind depends? So they go by different names. DevOps, SRE, sysadmin, engineer, whatever they call themselves. This is what they do. They make sure that the servers are running. They make sure that if there are any problems that crop up in any of the applications that are running there, those are getting fixed. They make sure there's no downtime. And I think that they're not really given their due in today's world. A lot of the general population don't understand how crucial the work that these people do is. In fact, I think that they probably themselves don't realize how crucial a cog they are in today's world. And if they weren't doing, what they did on a day-to-day basis of looking after all these applications and servers, then a lot of what we take for granted in the world would be breaking down. So the global community aspect here is, how do we empower all of these people who are already, trying to do the best that they can, and how can we give them the tools to go further? And that's where the equip to troubleshoot bit comes in. So troubleshooting is hard, right? Anybody who's done troubleshooting on any sort of system knows that it's not easy. It's not easy to identify issues really quickly. It's not easy to get to the root cause super fast. It's not easy to get to the right root cause because there's a ton of things that could be going wrong. And it's really hard to look at the symptoms across thousands of different metrics, across different systems and nodes, and then be able to predict what's happening and prevent problems from happening. So it's really hard. And we already talked about the fact that this has real world implications, right? We're talking about critical infrastructure, healthcare, transportation, agriculture, and so on. So if it's hard to troubleshoot and there's major issues impacting services, then that has real world implications, right? It's affecting people's lives. So what this means is that the people who are doing the troubleshooting need to be equipped with the best tools. Going back to the Batman analogy for a bit, Batman had a lot of gizmos and gadgets and the Batmobile and everything else to go after the bad people. So our DevOps and SREs and sysadmins and engineers, they need some cool weapons in their arsenal as well to be able to troubleshoot, to be able to monitor, and really get to the bottom of these things and fix any problems that might crop up. But the other aspect here, which is really key, is that the playing field also needs to be level. We have a very diverse set of people who are in these roles, who are doing DevOps work, SRE work, sysadmin work. There's people who are in large corporations with billion-dollar budgets and large teams to do this stuff. But there's also people who are, running very small startup teams, not-for-profits, universities, and just solo entrepreneurs doing stuff. So there shouldn't be a big difference between what somebody with a lot of money in the bank is able to do in terms of monitoring, in terms of troubleshooting, and the tools available to them, versus what somebody who doesn't have those resources have. Because if that is there, then then the process isn't really helping the global community overall. So what we're trying to do at Netdata is that we're trying to level that playing field a little bit, and this is something that we take very, very seriously. So some of the things that we really focus on, number one, is a really low cost of ownership, the lowest cost of ownership in the industry, if you will. And what this means is that the Netdata agent is open source. Netdata itself is free for everybody to use. And even if and when we launch a paid plan in the future, all of the cool features that you're using right now will be free. And cost of ownership is not just the subscription fee, but it's also what it costs in terms of system resources to be able to run Netdata. So that's another area where we're really focusing to make sure that the agent that gets installed on your servers is really, really lightweight and it doesn't, eat up a lot of your resources. The next point is that it should be easy to install, as minimal configuration as possible, and it should be simple to use. Because again, we're talking about a diverse set of users from different backgrounds, different countries, different languages. It needs to be easy for them to understand what they're trying to do with the tool so that they're getting maximum value out of the tool. So that's another area where we really focus on. The third one is zero compromise on data privacy. So you might have heard people say that, if the service is free, then, it's not really free. You're paying for it in data instead of in money. That's something that we want to avoid at all costs at Netdata. Because what we're trying to do here is that all your data is stored on your servers, and it's only the metadata, and we're very clear on what metadata that gets retained by Netdata servers, and everything is just streamed to what you see in the Netdata app. And finally, the other aspect is that the most advanced features, which are most critical for troubleshooting, for monitoring, for observability, we want to ensure that those things are available for all users for free, and they're not hidden behind a paywall. And that gets us into machine learning. So when we add machine learning based features, we want to ensure that they're available for all Netdata users. So I'm not going to go into what machine learning is. I'm sure all of you know that. It's basically the ability for computers to learn without being told explicitly what to do. And machine learning can really help turbocharge monitoring and observability because it can help teams make sense of large, complex data sets. We're talking about huge amounts of data here. In large infrastructures, we could be dealing with hundreds of thousands of metrics across thousands of nodes. So there's really a ton of data, and it's really hard for humans to just make sense of all of it at the same time. So any help that we can give the users in terms of making sense of all of this data and getting the key insights out of it is useful. It also helps in terms of detecting patterns and anti-patterns. So what's really going on across different nodes, across different metrics, and what are the useful insights that can be gleaned out of that. And also for surfacing useful information at the right time, because what we don't want to do is just throw a bunch of data and throw a bunch of information in your face, and then you have to make sense of all of it on top of all of the other stuff they have. So it's about bringing the right information to your focus at the right time, not really flooding you with too much information. And the ability to do all of what I just explained faster and at a lower cost than before, than being able to do it manually, is where machine learning really shines. And there's a lot of different areas to DevOps and system reliability where machine learning can really help. It goes from things like reactive solutions where the user detects something and then they click on something, and then the machine learning feature kicks in and then tells them or gives them an extra layer of help, to more proactive solutions where the system itself is bringing information to your notice as a user and saying, hey, this could be something that's going wrong. Maybe you need to look deeper into this. And there's also if we take it further, there could be predictive solutions where we're looking at certain signs and trying to give a likelihood of this is what could happen, or this is the likelihood of something bad happening before it actually happens. And of course, going even further, you could have prescriptive solutions where beyond just showing you what's happening, it could help with suggestions of here's some possible things that could help with the situation. But again, there's a lot that could be done, but all of this it's not an easy road. There are a lot of challenges as well when you deal with machine learning. I just talk about some of the challenges here before handing over to Andy and then talking about how we do things at Netdata. So the number one thing is that the results from any machine learning solution that we use needs to be interpretable and explainable by the users. So they need to be able to understand, why we got a certain result. If we said something was an anomaly, why did we say that? It needs to be clear. It needs to be something that they can explain to other humans in their team. It shouldn't be something that works purely as magic. And we shouldn't be asking users to just trust us because we know what we're doing. It needs to be an interpretable thing. And secondly, we need to always keep the humans in the loop, because the humans are the subject matter experts here. Let's not kid ourselves. Machine learning that we have at the moment, it doesn't have the context that our human experts do. So it's about getting all the right information, getting all the right context, and then bringing it to the human experts so they can take the final decision. The third point is cost of ownership. So this is a really important point when it comes to machine learning. I've seen machine learning features that that are really great, that do a lot of awesome things, but then to run it, you need a really powerful machine, or it's going to eat up 90% of your CPU when you turn it on, or you need a really powerful cloud instance or a GPU rig or whatever. And what that means is that such a solution is basically out of bounds for most users out there. They can't really turn it on, so it's not really useful. So performance is a key consideration here. And then finally, protecting users' data privacy. So to be able to build these machine learning solutions, we shouldn't have to take a bunch of user data and then do training on it. We want to be able to do it in such a way that the data remains with you and the models can be trained unsupervised, and it still works. It's still doing what it's supposed to do in an as accurate a way as it can. So with that, I think I'll hand off to Andy. We can get into how we've been doing machine learning at Netdata and interactive demo, if you will.
Thanks, Jan. First off, shout out to the 4 a.m. Hardcore user in New Zealand. Thanks for joining us. Fair play. So this next slide is just a quick one before we get into the demo. That kind of builds on some of the stuff Shan was talking about. It's a lot of hot takes basically for me, and there's a blog post there about it with more detail on each of these bullet points. I'll quickly go through them one by one, super quick, and then we'll get into the demo. First one, no nonsense ever. This is kind of obvious. A lot of companies, they pretend like the ML is some sort of magic, and sometimes you read their docs and you're left none the wiser. You can't even figure out what it is they're actually doing. Like, how are they? The hardest part of ML is kind of formulating what the inputs and the outputs are. And a lot of the times, companies don't even make it clear how they're doing that. So as a user, you're not really sure kind of when you're using the feature, where it might fail, where it might be useful, and what its pros and cons are. So that's number one for a reason, basically, is that we're never going to kind of overplay these things or dress them up or buy into all the buzzwords. Our plan is to be as open and transparent as possible and always show you the code. It's there. We're not going to not tell you what algorithm we use. We're going to tell you, like, the whole thing we're about to see is based on k-means. We have a whole Python notebook that actually goes through it. So if you're interested in that sort of stuff, you can look at it. Second one here is this is a particularly hot take. This is that observability is actually a little bit behind when it comes to ML. This is kind of like a personal observation I have from the last few years, since I'm kind of working in this space, is that in other industries like finance, advertising, ML is just like a normal, it's not even a special thing. It's, you have fraud detection. It's just part of what banks do. You have a CTR prediction for ad tech. That's just how it works. Recommendation engines, that's also just how things work on, Netflix or anything basically. But when it comes to observability, we're still sort of just looking at dashboards and looking at metrics, and we're doing a lot of stuff recently has like really fancy plumbing, kind of plugging things together, logs, metrics, traceability. A lot of fancy plumbing is getting really good at pulling all the data together. But at the end of the day, you're still kind of just looking at old school charts and metrics, and there's a few companies and a few places that are starting to change this. It is starting to change, but it's surprisingly still a little bit behind, which is good because it means there's lots of low-hanging fruit, and there's lots of stuff for us to be working on. So that'll be more talk of this in the at the end when we talk about kind of next things we're looking at. Number 3 is monitoring agents don't need to be dumb. So this kind of builds a little bit on it, in that we have all these agents. They're very fancy, but they collect raw numbers and they send raw numbers. They collect the number, they send it on, collect the number, send it on, and they don't do anything with those numbers, which kind of means that most of the ML solutions at the moment you have to centralize all your data into some cloud, and then then they'll just throw the kitchen sink ML at it because they can do it. The computation is happening in the cloud. You pay for the storage, and sometimes you pay for the compute as well. And kind of our point of view is that doesn't really need to happen. There can be some intelligence at the edge, like the monitoring agent can look at the number and also do a little small bit of computation, or also if the monitoring agent actually has these superpowers where it can do push button ML, where you want to say, like, show me all the metrics that are similar to this metric. That's not that hard for an agent to do, especially if it's like a parent agent, and so you don't have to, you can bring the computation to the metrics a little bit more. So that's kind of one of the ideas behind a lot of what we're doing. And the next one, beyond raw metrics, that kind of builds on it again, which is that, for instance, the Netdata agent now, since a couple of nightly releases ago, the Netdata agent is one of the only agents that, actually the only agent that out of the box, it gives you the raw metric, but alongside every raw metric, you now have this 1 or 0, which is the recent data, the recent metric, that we have for this data, is it anomalous, yes or no? And you just get that for almost free out of the box, for like a tiny minuscule amount of CPU overhead. And so the idea is here, if we can have this anomaly, we call it the anomaly bit because it is a literal anomaly bit. It's a 1 or a 0, and it's in our internal representation, so there isn't any extra storage overhead with it. then you can actually have some context to the raw number. So you get a raw number, but now in addition to a raw number, you get this 1 or 0, which is a first attempt at some context on this number to say, well, okay, I have this raw number. Is it strange or not? And this 1 or 0 is a first attempt at answering that, which will be kind of like a foundation we can use for lots of other stuff. Innovate, but resist being too fancy. This is also, we see a lot of people, they go straight to deep learning. They go straight to, throw the kitchen sink at it. Use your fancy libraries that are the hottest thing, especially with forecasting. There's lots of automated forecasting libraries that people use, but they don't really look into the assumptions that you need to have in your mind when you're using these time series forecasting, for example. And recently, there's actually been a bit of a backlash about some of these kind of Facebook Profit and all these automated forecasting. They haven't actually changed the world as people thought they would. Which applies here for us. We've picked an unsupervised k-means, so unsupervised clustering approach. So it's kind of like a middle. It's not as simple as like a z-score. It's not as fancy as deep learning autoencoders. It's kind of in the middle. And the idea is we can do this efficiently and have all of these pretty useful models. But when you have them across all of your metrics, the sum of the parts is more than each individual model. So we're trying to do kind of good, honest ML with sensible implementations, so we can do things efficiently. And we're not getting too fancy yet. We want to get fancy eventually, but we're not going to, we first need to prove what the inputs and the outputs are, what the API is, and build the product features. And then later on, when we want, we can easily swap out, instead of k-means, we can do some sort of deep learning models based on in an ML layer in the cloud, and that'll be what produces the 1 or 0s. But the main thing we need to focus on at the moment is the actual product, and the UX of it all. Human in the loop as well. So nowhere in anything that we're going to look at do we kind of say we've got a self-driving server or any promises like that. It's always more about like Netdata. Any of the ML features in Netdata should be there, a click or two away to help you kind of just get out of Netdata quicker, basically, and get on with your life. So it should be kind of assistive, so that instead of having to manually scroll, or instead of having to search for a needle in a haystack, maybe Netdata can help with some suggestions. So for instance, like, it might surface things that look anomalous, and you might say, I disagree. Oh yeah, that might be worth looking at, and then you go and check it out. So human in the loop is a big thing here. All we can do is say, we think the data looks strange. We don't know if it's something that means your server's about to fall over or anything like that. It could just be strange, but maybe it's just a different traffic pattern to your website, say, and it's no biggie. Or it could be a DDoS attack. Sometimes they can look kind of similar, and the ML can't really make a judgment on that. 3 more. So Lego blocks is the last one. Lego blocks kind of builds in again in terms of what we were talking about with this anomaly bit. So if we can put in place these capabilities in the agent, capabilities in the data representation, so that we now have these 1 or 0s, which are the anomaly bits. For any time slice of data, you can now have for every second we have the raw metric, and we also have this 1 or 0. So as soon as you go beyond 1 second, you now have an anomaly rate, and we have this anomaly rate now as a core building block. So you can do an anomaly rate across time, you can do an anomaly rate for any individual second across all your metrics, or you can do an anomaly rate across kind of any matrix or any combination of these things. And so that's why this anomaly rate is like a sort of a Lego block, as is the metrics correlation feature, which is another feature which is more focused around kind of change detection when you already have an idea and you want to see what else changed. So if we can build these sort of Lego blocks throughout the product, then they might be helpful. And as users get more educated on them, they might know which one might work best for which type of data or in which circumstance, and basically get to their answer quicker, and then get back to their life. Embrace uncertainty. This is one, ML, we apply ML to all these things, but it's never concrete. There's always kind of edge cases that don't quite fit. There's always, it's not the question I get a lot the last 5 years has been like, does it work? Does the ML work? How do we know the ML works? And what we're trying to do is, especially in unsupervised anomaly detection that we're talking about now, you don't really have an answer. You could, if you were to, Google, you could spin up, a server farm of different types of infrastructure, different types of chaos engineering attacks, and you could maybe then start, building labeled data from that. But it's just so complex and hard, especially to do in any realistic and meaningful way, that you could spend a year doing that and you still wouldn't really prove beyond a shadow of a doubt if things work. It would just be too superficial. So the idea here is that we are going to embrace that uncertainty and try and actually not let it slow us down to ask ourselves, oh, does the ML work? It's more about, is this useful to our users more often than not, as opposed to, is it a 90% accuracy, or any of these concepts that people have that don't really exist, especially in things like troubleshooting, where it's very subjective. You could have two humans look at the same chart and disagree on whether it's an anomaly or not. So there is no definition of accuracy really in a lot of cases, and that's okay. And then the last one is just about minimizing learning curve. Really, that's kind of just making sure that when we, for instance, we have documentation to back up, okay, what is an anomaly rate? How does it work? To make it as easy as possible for users to get comfortable with these kind of Lego blocks that are going to be in different parts of the product. And not sort of, we're not going to dress them up as, magic behind some black box that you don't ever need to think about, because there is cases where, for example, the k-means algorithm it doesn't work as well on steppy type of data because there's just not as many data points to do proper clustering on, whereas it works better on data that has lots of observations. That's something that, a user should be easily able to pick up from a quick scan of the docs and using the feature. And that makes it easier for them to actually understand then, where its strengths are and where it might not be as reliable as they might hope or whatever. So that's a main aim there. Let me quickly then, jump into the demo. I don't think I was too quick there. I think I was slow. So demo time. We're going to jump into a demo of the Anomaly Advisor, and the main aim of this new tab in Netdata is to answer two questions, which is, when did things look strange? At what time did things look strange across my infrastructure, so across my space or my room? And what, once you find that time that looks strange, can you tell me what metrics looked the most strange? So give me kind of, what looks strange, when did things look strange, and what looks strange within that window? And then it's kind of the human in the loop to decide, is it actually an anomaly for starters? And is it an anomaly I care about? And strange here is basically based on our anomaly bits, which is our distance to the trained clusters. There's lots of details here. There's a deck that goes into a lot of detail. There's a Python implementation. The implementation in the Netdata agent is, super efficient C++. But there's a Python version of it here. So if you are interested in understanding actually how it all works, there's a Colab notebook you can just click and run and play around with. So with that, let me just jump into Netdata Cloud. Let me just take a quick second for any questions. If there's anything, I haven't been watching the chat. Are any questions? Are we okay to keep going with the demo and then do questions after?
Yeah, I think we're doing questions at the end, so we can keep going with the demo.
So this is an interactive live demo. So I'm going to send some instructions now in a sec. What we have here is I have all the code for this demonstration, for this config. We have our ML demo space here, which has 7 nodes in it. And all these nodes are kind of every combination of configuration, basically. So in the Netdata community repository, there is there's a Meetup section, and there's a folder for today. I put it in the chat. Oh, it's in the chat already. And basically what we have here in the code is it tells you about, here's all the nodes, here's what they are set up. The names are pretty obvious. Like there's a parent, there's a node with ML enabled, there's a node with ML disabled, and this one with the ML disabled, the parent will actually run the ML for. And then there's kind of non-streaming orphan versions of those two nodes as well. So like this node doesn't stream to the parent. It's just a node that just does its own ML and just is doing its own stuff. And then this is a node that doesn't have ML to say enabled and doesn't stream. So there be no anomaly scores for this guy because it's just turned off. And then this last one here is the Meetup node. This is the one I'm gonna share the IP address of this one, and people can go in and click around on the local Netdata dashboard. And we have there's a little ML app running on this thing as well that I want us to go and click some buttons on, and then we'll actually watch how that plays out in the Anomaly Advisor. And so the code for all this, like the config is all in the scripts, and the Terraform is in here as well. So if you're interested in kind of seeing how we do all this configuration, it's there for you to look at. So let me jump in. So what I'll do is I have instructions here somewhere. These guys, and I'll do this as well. Let me put this in the chat. And I'm going to delete these. This VM is going to die after this, so it's okay sharing the IP. So first step is I'm going to go to this local dashboard. This is the local Netdata dashboard. And Why is it refresh that didn't work? Okay, got my internet was on there. So let me have a look and see if these guys are running. Yep, we're running this local dashboard. Okay, let's see. I don't know why this isn't. Maybe are we? Can anybody get this?
Can you try it again, Andy? It works for me. It just opened up right now.
Oh, it works for you. Okay. Maybe we've given it the hookup there, have we? Well, let me see. So let's actually just jump into the Anomaly Advisor tab here and see. So I if I can get in, okay, I can get in here. I can go on, and what I'll do is I'll because I want to hit the ML app. So what I do here is I selected like last 30 minutes and just grab this URL, and on the same server at 29999 is this little ML app that we have, which we use for kind of proof of concept stuff. So if I just hop over to the other port 2999, I should see this little sort of ML app, which is just a little Python dash app that we use. And there's we do this for proof of concept stuff. But one of the things I'm going to just do here now is this clustered heat map. So if I grab the URL from here and I just stick it in here, what this is going to do is it's going to actually pull the local net data last 30 minutes and do a clustering algorithm and give us back a sort of a fancy looking clustered heat map, which will show which metrics are kind of have the same or activate at the same time. And probably actually if I go back into here, we can see, yeah. So what we can see here at the moment is we're in the Anomaly Advisor tab, and we have a time series for each of our nodes. And what we can see here is that this blue node is after going pretty anomalous, and it's gone up to about sort of 8%, 6% there at the moment. So if I take this particular time step here,
so
what this is telling me,
so what this chart is actually showing, it's showing the percentage of total anomalous dimensions. So if you have 1,000 dimensions and it's 7%, then that means that 70 dimensions, 70 metrics are anomalous right now. So when Andy went and ran that, we see a spike here because there's a bunch of new stuff that's happening which hadn't happened before on that node recently. Yep.
And so you can think of this as previously we have all of our raw metrics every second. It's a big matrix of data. What this is doing is, instead of the raw metrics, it's now the anomaly bit version of that. So it's a big matrix of ones and zeros. And for this particular second, 17, 33 seconds, if you just sum up that column for that 1 second, the average of that is going to be 6.5%, which means 6.5% of all your dimensions were anomalous, which, as we can see from here, is much more than normal. Typically, about 1% of dimensions with the default ML config are randomly kind of anomalous on and off. And so when you see an elevation at the same time, that's a good sign here that there's some sort of anomaly. And so how I would use this is I would say, okay, this blue guy here, and we can see it's the ML enabled Meetup node, which is the one we were all hitting. What I'll first do is I'll filter down because this is the one I'm interested in. And I'll just kind of pan it here so I can just freeze on this window of time. And I can basically highlight the area of interest. And when I highlight the area of interest, what's going to happen is Netdata Cloud is going to go and ask this agent for this particular window of time, which metrics were the most anomalous. So every 30 seconds or so, the Netdata agent has a special chart that is like an aggregation of all these anomaly rates per dimension. And it's every 30 seconds it aggregates this. So for any kind of any time frame you can ask the agent, it'll hit this endpoint and give you back a list of which things were most anomalous at that point in time. And that's kind of that's what we see here in this heat map below. I'm still calling this a heat map, even though it started life as a heat map, but now it's more like a sort of a spark line. I'm not sure. We need to come up with a better name here. But the idea is basically, if I look at the first dimension here, IPv4 packets received, we can see that the 41% of the highlighted time, it was considered anomalous by Netdata. So again, this is just the ones and zeros in this highlight. 40% of them are ones, basically. And this chart,
when Andy highlighted that bit on the top, what we're seeing here now is a sorted list of the most anomalous metrics during that time window. So you see that something that's crazy going on a particular node or a particular instance, you highlight a window, and then you get all of the main culprits, and then you can see, what was going on specifically for those metrics.
Yep, and that's you can kind of view the heat map, or there's a sort of a condensed version here on the right hand side, which is like a table of contents that you can kind of quickly scan if you have an idea of maybe some things you might be looking for or not looking for. For instance, I can see here, because we all went and hit this endpoint here, this is actually the you can see that that's this container here, the C group Netdata ML app CPU per core. We can actually see if we expand down the chart, we get back to now the raw, the normal raw chart that we're used to from the overview screen. That's what this one is. For this particular dimension. So we can see like the raw value, there wasn't any kind of CPU activity. And then we all started doing some work and it came to life. And as a result, then the anomaly rate correspondingly jumped. And so the idea is you can kind of quickly scan this and see what's going on. We can see some IPv4 packets delivered, received. We can see this container was doing some work. And it'll probably be a lot of other stuff that's kind of related, network traffic. So, a lot of these are going to be kind of similar network sent. So we can see, for instance, this is a good one where, typically there's just some background kind of noise. And then once we started, this could be also when we hit the local dashboard, there was network traffic, and when we hit the ML app. So both of those would have had network traffic to your browser, and we can see that's what's going on here. And
I think there's a question, Andy, related to how we sort this from Luis. The question is, why are we sorting by percentage and not by time?
Yeah, so this is a good one, because what we do, we don't really sort. The time is kind of implied in that you could see, and sometimes you can see that maybe there's a peak first. You might highlight the whole window, and we can see, for instance, here we can see that actually the network stuff happened. The networks, like this is actually a good one. So you can see the network stuff here happened just before the container started doing work. And that was obviously me trying to hit the local dashboard. So there's kind of like two anomalies here, which is I went to the agent dashboard and I started doing work. That's what would be in this network traffic. And you can see that that's what happened first. And then, once I finally got my URL, I was able to copy the URL into the container. And then you can see it sort of happening here. So there is some sort of time, but it's indirect.
Yeah, I also think that indirectly what we're trying to show here is related to time, but in a different way. We're saying during the highlighted, selected window, how much of it was that particular metric? How much time within that window was a particular metric anomalous?
Yeah, and that's what this is. So this 41% here, if you kind of squint, you can see that roughly, this green guy is at 100% about roughly. If you were to just average this, basically, these are all, because these are more than 1 second, these are all now floating point numbers, so they're rates basically. And if you were to just average this little snippet of green, it should be about 41%, which is kind of like a time weighted way of doing it. But it's a common question that's come up, like, is there a way to also order this by what happened first, or is there a way to maybe turn this into a graph of events and actually trace which things happened first? It's something we could do, but it's a little bit trickier to do, but it's a good question. And there is one thing I haven't mentioned here, which is we do have anomaly events. So there is sort of Netdata, the agent can also define anomaly events. And so you could kind of have a sequence of events that we could do some sort of, like, we can see here, this event happened, but really Netdata is not going to tell, it's not going to differentiate between my local dashboard anomaly and the anomaly if they happen at the same time. So that is something that we would like to try and kind of work on later, is like, how could you actually group these into their own clusters within the anomaly, say, and actually kind of maybe make a graph view to see how things kind of trace through. But it's a good question, and it's something that has come up before, like, different ways to order this.
Yeah. I think it's a really good point. And what we do with events today is basically, if you have enough anomalous metrics in a particular node or a particular instance, then we detect it as an anomalous anomaly event. And then if you're looking at the view across multiple nodes, multiple servers, you can actually see if there's sort of cascade happening from that, like one anomaly triggering off a bunch of other stuff.
Yep. And one thing to, while we're here, one last little thing to just kind of think about, to have in your mind, by default, the ML trains on the last 4 hours of data. So it should usually be that when you zoom out and you put about 4 hours in, that's all the ML knows about at the moment. That's one of the next steps. We're going to try and extend that 4 hour window to be like 24 hours or unbounded. But you can see here, if I get about 4 hours in, and this is probably an easy one because there's never much traffic, a little bit of traffic here, but there's never any spike like this. So it's obvious for me, from my human eyes, if I look at the last 4 hours, I agree, yeah, that was an anomaly. And if you want, you can give us a thumbs up because we kind of use these to see which dimensions the ML works better on versus doesn't. But that's one thing to bear in mind is like the ML only knows about what it's trained on. And by default, at the moment, it's 4 hours. But pretty soon, we're going to try and extend that to be 24 hours or more. But we have to do it in a way that has like no extra impact on the agent. Basically, that's always the big challenge here as well. So yeah, that's pretty much the demo. Is there any other questions or? Alerting capabilities. Yeah. So actually, that's a good this is a good kind of thing to I'll quickly talk about because I want to cover this as well. So we have implemented this as an anomalies tab. There's no really alerts built in here yet because we want the ML to like prove itself that it really stands up and works, because Netdata, part of what Netdata is kind of, we're very proud of, is our kind of painstakingly tuned alerts. There's no, they even though we all have alert fatigue sometimes and they can be painful, it's kind of, there's no real perfect one size fits all. So we're constantly tuning the alerts out of the box. There is a way that, because we've implemented the anomaly bit, there actually is a way to do ML alerts if you want. And that's what I've done in here. I'll quickly, actually, it's in the code. So in the scripts, that the startup scripts that do the config, there is at the end, there is example of anomaly based alarms. So you can see here's one where it's taken the 1 minute CPU usage, and the only thing, the thing to bear in mind is basically we have this new option called anomaly bit, which lets you actually just any alarm, you can now also define it. Instead of on the raw data, you can define that alarm on the anomaly rate itself. So if you want, you could actually do something like this, which would say, give me a warning when the anomaly rate goes above 5% for, the 1 minute rolling anomaly rate goes above 5% for CPU. And if it goes more than 20%, give me critical. So you can do it at the individual chart level, or there also is, you can do it at the node level, because we have this anomaly rate chart, which is basically showing the overall. It's this top here. This guy here is just a chart like any other. So you can obviously build an alert on this chart if you want as well, just like any other chart. And then you would have, okay, if the anomaly rate goes above 1% or 5% for more than a minute or two, maybe give me a warning or a critical. We haven't really configured these out of the box yet because we're not sure. We don't want to kind of confuse alerts with the ML based alerts. We want to make sure, this is what people always do. People always ask for like dynamic thresholds and they want these fancy alerts, and it never really works. There's actually a good Prometheus talk on YouTube. I think that's in one of the playlists that covers this. It's really not solved. So what we do have in the repository, we have we've put in, there is an ML conf in the health, so it's just commented out. So if you're curious, you could kind of play around with it. There's an ML conf in here that shows you how to do just like any other alarms. It has alert examples, but they're all commented out. So you could kind of play around with this yourself. And I actually have this turned on in here. So let me refresh this. So
I think there's also
there's
I think we're going to cover in the coming soon section as well, Andy. Like there's more stuff around anomalies plus alerts and ML plus alerts that's coming soon in Netdata.
Yeah.
So yeah.
I'll just do one last thing here, which is this. I have enabled the alarms collector. So we have the Python alarms collector lets you visualize these things, and I filtered it down for just the ML alerts. So what you can see here is actually, the area I had highlighted was, if I go back to the anomalies tab, it was the area of interest was anomalous. And you can see pretty soon after it, all these alarms come to life because the individual anomaly rates also came to life. So if I could make alerts based on this if I wanted to. We just haven't done it by default out of the box yet. So, but we would love any feedback for anyone that kind of is interested in playing with that, because I think it could be useful, but we just don't want to kind of we're being super careful with, kind of any confusion around alerts or anything like that. So yeah, I think that's most of the demo stuff. Let me jump back into the slide. Let's see. So yeah, there's links there, and basically next steps are kind of just try it yourself. So it's been enabled ever since the nightly a few releases ago. It's enabled. If you're on an older version of Netdata, it's like a 1.9 config change in your netdata.conf. And there's lots of links here. There's a community post. You can give feedback. You can come to Discord. There's a YouTube playlist of like just general Anomaly Advisor or anomaly detection videos that I maintain. If you're interested in it, you could kind of go there. There's good stuff in there. And then this is the last kind of part, I think, which is just around feedback challenges coming soon. I'll start, and then maybe Sham, you can talk about all the coming soon stuff, because I know you're kind of keeping us all honest with that. So feedback and challenges, number one is kind of resource impacts on the agent. So we don't have the data. We can't obviously, the ML for the monitoring can't obviously impact what it is that's monitoring. So typically what we see is it's like about 1% of one core on CPU is about sort of the budget that we see, and so it's very minimal basically, and that's kind of because we've picked k-means. It can be done really efficiently under the hood, there's lots of optimizations on the data, and we also then do, obviously we don't train it all in one batch, we spread it out. We kind of try and do just smart optimizations so that we're very careful about any overhead on the node itself. That being said, if you are running like an IoT device on the edge that maybe just can't do it, you could obviously stream that to the parent, and then the parent can just run the ML. So there's lots of kind of configuration options as well. And then just ongoing stuff, we're trying to extend the training window. So obviously just the ML only knowing about the last 4 hours, that's not good enough. It needs to know about the last 24 hours or maybe even longer. And then there's other stuff like there's always going to be bad models. Like for instance, we have one problem where if you have a metric that's kind of constant, or maybe it just changes once or twice, and you then fit a cluster on that, it's kind of going to be garbage in, garbage out. And that's just, there's no way around that for now until we kind of have some way to maybe filter out bad models and things like that. But also, if you try and do any logic like that, that's going to be extra compute on the agent. So there's always a trade-off, So there's lots of stuff like that we're kind of working on. And all these things, they live in the GitHub discussions. So anyone can kind of just follow along and contribute. And then coming soon, Sham, I'll let you kind of talk about all the good stuff coming soon.
Thanks, Andy. Yeah, so the first one there is anomaly rate everywhere. So what we just showed you was the anomalies tab of Netdata. So this is what, if you want to explore anomalies, you would go to the anomalies tab. But what we wanted to do with this is to be able to take that anomaly rate information, since we already have it for every metric, and bring it to all of the other charts, your overview page, your single node view. And if, I think Andy's showing you right now, if you're looking at a particular chart and then you see that, you're wondering to yourself, is this an anomaly or is this just regular behavior? I see a spike there. You can just click on that quick find anomalies icon there, and then it just pops up a smaller chart above, which is showing your anomaly rate. So you can see that, sometimes you see a spike, and that's not really an anomaly, it's just regular behavior. And you can figure that out without having to scroll through your timeline and stuff like that. So it's a quick and easy way to figure out, if you're looking at an anomaly or not. And if you want to explore further, then you can always, jump into the anomalies tab and then take a look from there. So this is now available for basically every metric, every chart that you see in Netdata.
Yeah, and you can see here, it wasn't until I kind of grouped by node that it became obvious that it was the Meetup. This is the same anomaly we're looking at, but we're just looking at the CPU. And we can see it actually, it was just this one node. It wasn't until I grouped by node, like when that it was obvious. So it's kind of,
we were hitting, yeah.
Yep. Back to the slide.
Yeah, the next one is, we're making a bunch of improvements to anomaly detection. One of the things is what Andy talked about in terms of extending training window. I see a few comments here which are also related to that, talking about, what happens when a cron job gets triggered every day, or, at 6 a.m., for example. So this is something that we are actually working on. So instead of just using a model trained on the previous few hours of data, maybe have multiple models trained on the last 24 hours, maybe even more, and then use it as a consensus mechanism to give you a final prediction of whether this is an anomaly or not. So we could then know that, hey, you see something spike at 6 a.m. because there's a cron job kicking it off. We could look at 6 a.m. the previous day maybe 6 a.m. some other time, and then say, is this really an anomaly or not? So the idea is that we can bring in, more context and try to learn better with more memory, basically. The next one is cross-node metric correlation. So metric correlation is, it's a different feature that we have where if you see a particular metric and it's exhibiting behavior that you're kind of curious about, you're interested in, you think it could be related to something that you're debugging, troubleshooting, then you can actually highlight that window where it's behaving that way, and then look at what other metrics in your system or across your different nodes was actually behaving that particular way. So this functionality already exists in Netdata on a single node. So you can look at in one particular server or one particular instance what's going on across all of your metrics. But what we're going to try and do here is to add it so that you can do it across all of your infrastructure. So you have 100 different nodes running on AWS. You see something weird going on, you should be able to say, what else behaved weirdly during this time across all of my instances. And then alerts in ML. So we talked about this briefly, but there's a lot of potential here of what we could do, not just alerting users when an anomaly happens, but also should we be notifying users for all alerts? Maybe some alerts are just things that happen every day. Maybe they're not interested in it. Maybe it leads to notification fatigue for users. So we could use the anomaly information as well as other ML to be able to say that, what are the alerts that users actually care about, and then give them the option, do they really want to be notified about it or not?
And one thing, actually, alerts, that's one thing I'm again, kind of in terms of like observability being behind. I think it's kind of crazy that people haven't just taken, you can talk about alert fatigue, and if you kind of just turn that problem on its side, you can almost think of it as, it's the same thing as advertising prediction, CTR prediction. There's no reason why you couldn't have a good alert rank or alert action alert CTR prediction, and that would be sort of really easy to get going with, and something that I'm kind of interested in exploring to try and help with alert fatigue. So I'm kind of excited about that. So that's another sort of potentially low-hanging fruit thing that I think we can really kind of make progress on.
The other interesting thing regarding alerts that we could do, and this came up in the conversation that I had with a user recently, is you could add you could have an external script be kicked off when a Netdata alert is triggered, which means that, if you're not around to monitor, let's say an anomaly happens in the middle of the night, then you could set it up in such a way using Netdata that you kick off a script which grabs a bunch of your logs, maybe runs a few commands, grabs the output, so that the next day when you come in, you say, hey, anomaly happened, and I already have all the data that I need to debug and figure out why that anomaly happened. That's pretty cool.
Yeah, definitely. And straight away, like one thing, and that's kind of part of the reason of putting this anomaly rate in every chart, is that when people get comfortable and if they trust, these anomaly rates and the ML, and that it's, it's typically more useful than not. One of those post alert checks could be, obviously, well, check the anomaly rate for the alert window. And if the anomaly rate is just, 1%, 2%, it's normal behavior. So it's a misconfigured alert. So there could be ways we could actually use the anomaly rates to sense check the alerts, and vice versa as well, which I think there's lots of stuff we could easily do, again, kind of in terms of like Lego blocks. There's no reason why you couldn't just sort your alerts based on anomaly rates, and obviously then exactly. At the top of that list would be the most strange alerts on average.
Yeah. And then finally, so this is something we're working on right now to bring information regarding logs into Netdata. So right now our focus is mainly or primarily on metric data. But then logs is another big data source that's sitting there waiting there. You could have critical errors, warnings, a bunch of other information in your logs. And then you could also use anomaly detection on logs to see if there's anomalous, logging that's going on, or behavior, or, log messages that don't usually happen that are getting triggered, and so on. So that's another big area. It's just something that we're getting into. So hopefully we'll have something cool there coming along.
Cool. I think we're pretty close to the end. So there's just this thank you slide. One thing I always like to call out is that for our ML, we actually use another open source library, which is dlib, machine learning library. So I always like to give a shout out to them, because we recently implemented the metrics correlation algorithm from scratch in C, and it's very painful. So actually, not being able to build on other libraries like this makes it a lot easier for us. And the other thing I think was just kind of Q&A. Is there any other questions? We think we've got 5 minutes maybe, so we can fire away if there's any other questions or discussions. I see some good discussions in the comments.
Yeah, I mean, you guys handled the QA during the meetup. That was
Any
amazing.
questions, one or two, or we can. And if there's no questions, there's links here. Basically, there's a launch post in the forum for the Anomaly Advisor, so feel free to just jump on there and give feedback. There's GitHub discussions. Feel free to open a discussion if you'd rather use GitHub. And then our Discord, if you're into Discord, if you're one of the cool people that uses Discord, feel free to hop in and kind of join the Discord server.
Yeah, we do after parties after the streams in Discord, so you guys are all welcome to join.
A lot of the discussions on GitHub, for example, are where we are brainstorming the right design to do stuff. So if you're into that kind of stuff, hop on.
I think we have a question from Axel D. What was the recent cloud provider change from Google to Amazon in any way related to machine learning, future development?
No, it's completely separate. Although one thing I would like to do, so we haven't quite built any. If you think of what I was talking about with the alerts, if we wanted to build like an alert prediction model, we could easily kind of use all of the alert clicks, or basically when somebody comes in and clicks an alert and they end up in Netdata Cloud and we can see that that's a troubleshooting session, you could easily imagine that being labeled data for this alert was sent by email. We saw them in Netdata a few minutes later. They become our kind of ones and zeros to say, okay, what's the CTR for these alerts? And then that could easily be something that we could build in an ML service using something like SageMaker in AWS. That I'm keen to kind of, that would be easy for us to do, but we haven't done it. We haven't kind of taught or done any of that stuff yet. But no, it's not related. But I'm always kind of keen to see what these guys have. Basically, GCP and AWS is the ones I'm most familiar with. But yeah, eventually there is a limit to kind of what we can do on the agent. And so like long term, I could imagine that I would like to have deep learning autoencoders, and it's basically a cloud layer and a cloud ML layer that doesn't necessarily store your data. It just kind of caches it and trains in mini batches. So we're still not storing any data, but we're also just moving some of the processing off the agent. And then you could imagine that the agents just pull down the latest trained models from the cloud, and they could have like the super duper fancy models, but we're kind of trying to walk before we run as well. And so that's kind of, there could be some cloud stuff that I'm kind of excited about. But again, it's like, we're not going straight to building a big cloud ML serving system because they're very, very complicated.
I think like Andy said, we're just putting Lego blocks on top of each other right now. So we don't want to put like, one giant piece on top and then everything falls down.
And we're still looking at ways for improve the user experience with the current Anomaly Advisor. So any kind of notifications and stuff that we can do in the future. So this is very early. So all the feedback that you guys have in chat, so please join us in our channels and share it with us, because the Anomaly Advisor channel in Discord, for example, is in the spotlight. The blog post is global pinned on the forum. So there are a lot of chances for you to contribute to this new feature and help us make sure it fits your monitoring workflow the best way possible. So please join us and contribute.
Yep, all feedback, good, bad, indifferent, is very much appreciated. It can be hard to kind of get feedback from everybody because everybody's very busy and just getting on about their lives. But it's really appreciated any feedback at all. So
even if it's,
we'd love it if you go try it out. And it doesn't have to be in a scenario where there's something wrong and you have to go and try to troubleshoot it. You can just explore your systems using Anomaly Advisor. It's a really fun thing to do. So if you're going to try and run a particular command or an application or something, just run it and then go look at Anomaly Advisor and see what's going on in your system. So it's fun.
Okay, guys, I think we're done. We don't have any more questions. We're up to an hour on this stream. This was amazing on the clock. Guys, you were amazing. How do you feel? Just
we brought it in just bang on time.
Just on time. Thanks everyone for listening.
Yeah, thanks everyone for tuning in, and see you next time. Good evening to all of you. Good morning to some people, some of our hardcore users in New Zealand, and enjoy the day. Goodbye, guys.
Thank you.